In this episode of Mrs. M's Math to the Masses in a minute or two, we need to explore another application of triangle inequality theorem, which says the sum of any two sides of a triangle is always greater than the third side. We had looked at the mathematical representations of this in the first video on triangle inequality theorem, and now we need to look at the possibility of, instead of being given the lengths of three sides to evaluate and decide if it was or was not a triangle, we need to look at the application. What if they only give us two sides of the triangle and we have to determine what the third length could be? So your answer will not be a number. Your answer will be a range. So the missing side length n, we've already determined, since the sum has to be greater, the two shorter sum has to be greater than the longest. If n were the longest, it has to be less than the sum. Likewise, if n were the shortest length, it would have to be greater than the difference between the two to make sure the triangle could close. So let's try a couple problems and see how it looks. So if we were going to look at 15 and 5, we would work our answer so that we're solving for n. On one side of it, we would say 15 plus 5 is 20. On the other side, we say 15 minus 5. The difference is 10. So the missing length is greater than 10 but less than 20. If we did it for this example here, our length n, when we add 38 and 55, we will get 63. When we subtract 25 from 38, we will get 13. The missing length is between 63 and 13 units. So if we're going to solve with this example, we would say it has to be less than 68 but greater than 12. Now for this last example, the missing length n, less than 33 but greater than 11. That's an application of triangle inequality theorem, which, given two lengths for the sides of a triangle, you solve for the range of possibilities what the third length could be.